Welcome to Day 4 notes on thermochemistry, limiting reactants and thermochemical equations. Hopefully by now you're getting a little bit more familiar with this topic. It's definitely one of the more complex topics, and definitely the more practice you do, the better off you'll be with this. And I'm hoping you're getting the feeling like, okay, I'm getting enough practice here. If not, let me know. So after today, we're going to add into this mix thermochemical equations and calculating limiting reactants, which is why it's really important when we did stoichiometry that you could figure out those limiting reactants, because we're going to use that information in this lesson today. So remember that a limiting reactor is the reactant which yields the smallest amount of product. We had the excess reactant and the limiting reactant, where we're zooming in today on the limiting reactant. Energy in a chemical reaction can also help determine which reactant will be limited, the amount of product that can be made. So this is going to factor into that amount of product. Here's your example. How much energy is used when 14.3 moles of hydrosulfuric acid reacts with 17.1 moles of oxygen gas? Here's your equation. Now you're told here that we have to add in 175 kilojoules of energy. So you know that this is an endothermic reaction. We're going to take what we know. We know we have 14.3 moles of hydrosulfuric acid. And we're asked to calculate how many kilojoules. We've got 2 moles of hydrosulfuric acid, and we're given the amount of energy of 175 kilojoules. So the first thing I need to do is cancel off these moles of hydrosulfuric acid. So 2 moles is going to go on the bottom here. For every 2 moles of hydrosulfuric acid, we have to add in 175 kilojoules, so that's matching up here. We can cross off our units and calculate our answer, and we get a positive 1,250 kilojoules. Now I have to do the same thing for the moles of oxygen. I'm given the amount of oxygen gas. I know I've got 17.1. I need to find how many kilojoules. Now here I'm going to go up and grab the coefficient from the oxygen. So I know when I've got 3 moles of oxygen, it's going to need to have added a positive 175 kilojoules. I calculate that answer, do the calculations, and I should get a positive 998 kilojoules. So the oxygen is going to be my limiting factor. I don't have enough energy to do this reaction here. So when you're limited like this, you need to figure this out so you can figure out how much product you're going to get. This amount will be used. Here's your next question. Pause the video and see if you can tackle this one by yourself. Then check with me and see if your answer compares with mine. All right, let's walk through this. Here's the basic equation. How much energy is produced when 13.11 grams of tin reacts with 2.715 grams of nitrogen? So I write my chemical equation. We've got tin, Sn, plus nitrogen, remembering that it's a diatomic element. We have to have N2. Will produce this sort of reaction, which is basically a synthesis reaction. We have the tin combining with the nitrogen to form our product. And notice that heat is on this side. So heat has been produced. It hasn't been lost. So this is going to be an exothermic reaction. So here we have 13.11 grams of tin. We've got 2.715 grams of nitrogen. I have to make sure my equation is balanced. Let me go ahead and take care of that. Now I'm ready to begin. I know I've got 13.11 grams of tin. I need to figure out the kilojoules. I'm going to take my equations here. This is my grams. I'm just getting that right off the periodic table. I've got in 1 mole of tin. Cross off my units. Now, I've got moles of tin up here, so I need to grab this for the moles, number of moles used in my reaction. For each of 3 moles of tin, I'm going to have this much energy produced. So if it's on this side of the equation, I'm going to use a negative sign because it was lost as this reaction happened. Remember, this was produced on the product side. Put this into the calculator, and I get a negative 23.27 kilojoules. Now I do my second one. I'm going to be focusing on the nitrogen, 2 moles of nitrogen. Well, I've got grams here, so first I have to calculate the amount of grams in 1 mole of nitrogen, remembering that it's diatomic. That's going to be 28.02 grams of nitrogen. In each of these, I've got 2 nitrogen atoms, so I have to be sure that I'm taking the atomic weight of both of them, so I have a full mole of nitrogen. Now I'm going to use this to create a conversion. For each 2 moles of nitrogen, it's producing 632 kilojoules. So it was lost from this side. It was produced over here. So I've got a negative sign. Cross off my units, and my answer is a negative 30.62 kilojoules. I look for whichever one's the lowest. This is lower, so this is going to be my limiting reactant. So, we're finished with this segment. You can now move on to the practice portion and try a few more problems. For this, I'll also post a video that kind of combines a couple of these topics, so you can kind of get a review of all of them together.